Okay, so let's see the last question. Third, I was not able to solve in the comments, but fourth one was relatively very easy. So you just have to just we will convert it to a standard equation. So let me tell you how we are going to do. So first let me tell you the constraint, right? M and both less than equals to 250. Okay, now what does the equation say? Right, we have been given a grid of size m cross n. Okay, you may remove zero or more columns. Okay, we can remove zero or more columns, but there will be always one column, right? Okay, order must be same, right? Order must be preserved. Order preserved means like kind of subsequence, we can say, right? Subsequence, we can say. Okay, now a grid is called consistent, right? When a grid is consistent, right, if for every pair of adjacent remaining columns, right, every pair A comma B, the following condition holds for each row, right? So let's say I have two columns, right? One column is 1, this is column A, this is column B, value is 1, 2, value is 3, 4, right? And this is another example, A, B, value is 1, 3, 2, 5. And I say, right, limit equals to 2. Then tell me, are these columns consistent, right? If this A comma B pair is consistent, right? What is the difference here, right? 2. What is the difference here? 2. Both less than equals to limit, right? So yes, consistent. Okay, now tell me in this one, difference equals to 2, difference equals to 3. Are they consistent? No, because this one is greater than limit, right? So you got the basic idea, right? So for two columns to be consistent, we should check this condition for each row, right? The difference should not be greater than limit, right? For column A comma B, right? For each row, right? Difference should be less than equals to limit. Okay, this is the one thing, right? Now just tell me a question. Let me ask you a question, right? I have two columns, right? Is there any update? No, no update to anywhere. Then, then what? See. Can I tell if columns A and B are valid or not before solving this question, right? Yes. For each pair, check validity, right? So what we are going to do, we need a valid I comma j. This will prepare, and how we are going to do this? Okay, just loop, right? For I equals to 0 till what? And right, this n is column, right? Again, right? For j equals to 0 till what? I, what we are going to check, right? Each row, right? We need to check for each row. For row equals to 0 till, right, total rows, right, what we are going to check, right, I am going to check, right, grid of what is this value, right? First is row, right? What is my first column? J. What is my second column, right? Grid of row I, right? I need to check if absolute less than equals to limit or not. If it's not, you do one thing here, right? You define, right, flag equals to true. If it's true, it's fine, right? Else what do you do? Flag equals to, right, we do false, and at the end, right, here, right, here you are going to update, right, valid of ij equals to what, or value of flag, right? Now once I tell that, what I'm left with, right? So right, what I'm left with, now I don't care about the column values, right? Now we don't care about column values, right? So I have simply, right, an array, right? Just think I have simply an array with, right, two values, right? Let's say x1, this is some xi column, and this is some xj column. So for xi comma xj, right, to be valid, right, what is its value, right? Valid of ij, right? So it means now we have come to a point where, right, we only have to check if two pair of values are valid or not, right? Right? Two pairs are valid or not. What is this thing? That- Isn't this the longest valid subsequence question? Right? In that, what we do, right? We do like 1, 3, 8, 9, right? What do we do? We tell if each element is greater than or equals to k in the subsequence, right? What do I tell, right? Let's say if I take 5, is 1 greater than this one? No. Is this 1, right? So what I can do, 1, 8, 3, 9 is also a pair, right? So this one and this one, longest equals to what? Equals to length 2, right? Both of these are length 2. So is not this the same question? Yes. So yes. Now it's very simple question. So for this what we use? DP use, right? So where, right? DP of J means what, right? Longest, right? Valid subsequence, right? Till J column. And what is my value of DP of J, right? Right? What do I say, right? If I am iterating, or right, I from right 0 to n, let me say it's like this, right? Then the next thing will be, right, for J, right, equals to 0 till I. So then what do I say there, right? Right, first I check if it's is valid or not, right? If what? Can I just simply say in O of 1 can I do this, right? Because I pre-compute those, right? Now if it's valid, now this dp of j is my, right, current length of the longest subsequence, right? What it will be, right? Right, maximum of current comma, now one that is ending at, okay, so it's opposite actually I'm doing, right? Current comma, right, ending at j plus 1. What can be the new, right? So just think of this like this, right? 1, 3, 8, 9. The next I'm going to do is 8 and 5, 13, right? So just tell me, right? So initially, right, if we are this index, right, there's only one valid, right? Is 1 and 3 valid? No. So the maximum is 1. When we are at this one, right? When this is my j, right? 8, right? So initially it's 1. Then I check for j comma 3. Is it valid? Right? Yes. So what will do? 1 plus 1, which is 2. Then I will check for these pair, right? So is this valid, right? This is again 1 and this is valid, right? So I will do this plus 1, which is again 2. So what is the maximum value here, right? 2. Now, if I am at this one, is this 9 and 8 valid? No. So this value remains 1. Right? Let me change the color so that it's fine. And tell me, is 9 and 3 valid? Yes, right? So what is the maximum value now? 1 plus, what is there? 1, right? Comma 1, which is equals to 1. Now tell me, is this valid? Yes, and this is also valid. 1 plus 1 comma 1, which is again, sorry, 2. So again we have 2, right? Now if we are at the 13, now tell me, right? 13 comma 9, is this valid? No. So this value become 1. So now 13 comma 8, is this valid? Yes, right? If I have taken, right, my k equals to 4, right? 5. So is this valid? Is 8 and 13 valid? Yes. And what is the maximum value at here, right? 2. So what I'm going to do, right? So I'm going to do, right, maximum of what? What is the current maximum here? 1 comma. What is the maximum here, right? 2 plus 1, which is equals to 3. Okay, the next is this one. So again maximum of 3 comma 1 which is equals to 3, and this again I will check for last one, right? Maximum of what, 3 comma 1 plus 1 which is again 3, 1 plus 1. So answer equals to what, 3. So the same approach we use here, right? So what will your answer, right? Answer equals to what, right? Maximum value NDP. This is our answer. So what is the time complexity, right? For pre-computing valids, right? For pre-computing valids, what is the time complexity, right? We iterate over each column, right? Then we again iterate over each column, and for each column pair, we iterate over each row. Okay. So and what is the time complexity for DP? We only iterate over each columns only. So n cross n. So total equals to what? Of n cross m. Space complexity is what, right? Of n cross n. So this is our answer. Yep. What do you write? You are given a two integer grid of m cross n and integer limit. Okay. You may remove any zero or more column, but at least one column must remain. The relative order of the remaining must be preserved. Okay. The grid is consistent, right? If for every remaining columns with every the following condition held. The maximum, right? We have to return maximum number of columns such that all are valid, right? Two columns are valid, right? If for each row, right? This condition should hold true. What is this? So let's say I have one column x2, x3, and xn, right? I have to check maximum valid subsequence, I think. Okay. We have to tell the, I think, longest valid subsequence, and each pair is valid if we hold this condition. So I think we can use the DP here. Column equals to state. What we are going to do, we have to use the grid IP, right? Let's check which are valid. Check which column pair, right? Which column pairs are valid, right? And valid. Just like in Java, what am I doing, right? Valid, right? Anti-valid 250, right? 250 initially, let's say all are invalid. On invalid, right? For anti column equals to 1 grid dot 0 dot size, anti row equals to 1 grid dot anti equals to 0 I less than odd columns I plus, right? For anti j equals to 1 0 j less than what I j plus I have to tell if j comma I, right, is valid or not, right? Right, valid of what, j comma equals to, right, is valid, right? I'm going to pass it grid and ith column and jth column, right? Boolean is valid, right? Vector, right? Anti and grid anti a anti b boolean, right? Boolean valid equals to false. Return valid, right? Return initially it's true, right? For anti I equals to 0 I less than what, grid dot size I plus, right? For each row, right? If grid of what, I comma what, k minus grid of I comma b, right? The condition is absolute. It's greater than limit. So set valid equals to false. Break, right? This one is extra, right? I need limit as well. To limit. This is limit. Okay, we have pre-computed the valids now. Now we'll use the DP, right? use the dpRent vector int dp is for column comma 1, right? Each single is valid, right? For int equals to 0 I less than what? Columns, right? I plus plus. For int j equals to 0, j less than what? I j plus plus. Tell if this is valid or not, right? Not tell, right? If it's valid, no, sorry. If valid of what? J comma I 2 comma run, right? If this is valid, right? What's my current dp of I? Equals to maximum of dp of I comma dp of j plus 1. Return, what do we do, right? Maximum element, right? dp dot run. If right, we pre-computed n cross n, this is of 1. Let's say this answer should be what are we, boolean valid j comma, right? Use of undeclared. I did not valid. Okay, valid. Output should be 1. Okay, output is 1. Output is 1. On all cases, I have 1 output. I did G. Okay, this is GPU j comma I 2. Output 2. Last output should be 1. Okay, yeah.